All right, class, here's our day 3 notes, and today we're focusing on rotations. Okay, with rotations, we can either focus on rotational symmetry within an object, or we can take an object and we can rotate it to a new spot. So when you're looking at an object, a figure has rotational symmetry if it can be rotated less than a full turn meaning a full 360 degrees. So if you can rotate it less than a full turn about a point to a position in which it looks exactly the same as the original. Okay, so this design has rotational symmetry because you'll notice we could take it and we can split it into some equal parts. I drew a line right through the middle of all these little sections here. You'll notice that all 6 of these sections are identical. So if I took this shape and I turned this point from here to right here, it would look exactly the same. So we can say that this has rotational symmetry. And even more, we could figure out the degrees of how many degrees it takes to turn there. This one in particular can be rotated 60 degrees and look the same. Now you might be wondering, where did I get that 60? Well, if we know a full turn is 360 degrees, once we split an object into these pieces that are all congruent to each other, meaning where they all look exactly the same, we can just take the 360 and divide it by 1, 2, 3, 4, 5, 6. When I divide it by 6, that's how many degrees it takes to rotate from one section to another. So 360 then divided by 6 equals then the 60 degrees. So that's how we figure out our rotational symmetry within an object. Okay, so here's just a picture of your degrees to help you remember how degrees work. So if we start at 0, 90 degrees, it goes to here. 180 is when you take something, flip it all the way opposite, and then continuing all the way around 360 is a full circle. Okay, so the center of rotation is right in the middle of our object when we're thinking rotational symmetry. And then the angle of rotation is what we were just calculating up there. So let's do the examples at the bottom of your notes. All right, so when I look at this recycling symbol here, when I'm trying to find the angle of rotation, I want to look at how many equal parts can I split this picture up into so that when you turn it, it would look exactly the same. So if I place my center right in the middle, you can see that there are 3 equal sections, 3 of these arrows. So if I turn this arrow from here to here, it would look identical. Okay, so what I do to find the angle of rotation then is I take 360 degrees. That would be taking the object and turning it all the way around, but I split it into 3 sections. So divided by 3 gives me 120 degree rotation. Okay, so that's how many degrees it takes to rotate from here to here, and then another 120 from here to here, and then another 120 from here to here. So 3 120s is where we get our 360. All right, now if we look at the snowflake, we can see that we could draw a line right through each of these longer tips here. All right, and we could see that each of those sections are all identical to each other. So then therefore, the rotational symmetry on this, it's got a 6-turn or 6-fold rotational symmetry. So I would take 360 degrees and divide it by 6 to find the degrees from one to the next. And that would give me then 60 degrees, similar to that question up at the top. Okay? All right, now this hubcap one is a little tricky because when we notice this one, you have to pay attention to all the little details on here. You'll notice that it has 5 little holes here, okay? But then when we look around the outside, we've got to count the number of holes that we have there. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Now we won't be able to split it up into 10 sections because we only have these 5 little holes here. So the easiest way to break this up would be to envision putting each of these little holes into a separate section. So if that's my center, I could, and again, this is not going to be a perfect drawing by any means. We could divide it up right between each of those little circles. Okay, and essentially, if you look at these, you should have 1 and then 2 halves or 2 total holes in each section. Okay, same with each of these. They all have a full one and then the 2 halves in each section. So I have 5 equal pieces that I can rotate this hubcap into. So I'm taking 360 then and dividing by 5 to figure out how many degrees symmetry that would be. So 360 then divided by 5, that would be 72 degrees. Okay, so that's how many degrees it is then from one section to the next. All right, so that's finding rotational symmetry within an object, how many degrees it takes to go from one position to another and look identical. Okay, we can also take an object and rotate it to a new position, and that's what we're going to see on the next page. So go ahead and turn the page in your notes. Okay, let me slide this down a little bit. All right, so on these, on the first one here, we're saying what rotation is shown in this picture. So what we want to say basically is how many degrees did it take to rotate from one picture to the next. Okay? So on this one, I'll notice that I've got, these are my regular E, F, G, and H. So this is my original or my pre-image, and this is my image afterwards because it has the prime. Okay? What I would notice on this one, if I pick just one side, look at HG. HG was on the bottom, and it rotated until it was over here on the side. Okay, so it's going from here, almost horizontal, it's tilted a little bit, to almost vertical. So if I want to think about how many degrees that would be, oh, sorry, hold on, we're kind of going this way. Let's go how many degrees that would be to go from here to here. We would say, envision from here to here, thinking on a, we're starting here, we're rotating to here. How many degrees is that? Well, that is a 90-degree rotation. So we'd say it rotated 90 degrees, okay? And if it's going from here to here, we would call that clockwise, okay? Because we can either rotate clockwise or we could go counterclockwise. So this is going clockwise. Okay, so we're going to keep it pretty basic with our degrees and just do ones like 90 or 180 whenever we're envisioning them on a coordinate plane. Obviously, we could rotate at different degrees, but then it's harder to determine when it's not, when they're separate like that. So if we're just kind of envisioning going from almost horizontal to almost vertical, that would be a 90-degree rotation there. All right, now this one is telling me to apply a 180-degree rotation. That means I want to take the shape and completely flip it over. Okay, so if I look at this, if I'm going to completely, not flip it this way, but completely turn it all the way around, that means my A has to go from here, and I want to turn it, it's going to end up all the way over here. So it was at the point -3, 1. It's going to rotate over here and be at the point +3, -1. It's just completely flipping around. That's going to be my new A. Okay, and that's a full 180 is going to do that. It's going to flip it from one quadrant to the quadrant that's diagonally across from it. So the C, when I rotate this 180, is going to go all the way around over to here. So it's going to go from 2, 2 to -2, -2. That's my C prime. All right, and then the D, notice it's right there on the center that we're turning around. So just like that the other day, the D is not going to turn, or not going to change its position. So there's going to be my D prime. Okay, so then we can connect those points. And we should notice if we envision taking this and turning it all the way around, the A would go from here all the way to the other side, and the C would go from there all the way to the other side as well. Okay, so that's a full 180, takes this image and completely flips it upside down. All right, so that is your notes on rotational symmetry.